This time, let's talk about a glide reflection. This is actually one of the unique transformations of a certain point or even a line in a Cartesian plane. If we talk about a glide reflection, it is actually a combination of a reflection and a translation, or vice versa. We could start with a translation and then a reflection. Now, take note, this is actually very familiar. This is similar to the three reflections we talked about in the same playlist. It's actually another way of solving a three reflections of a certain point. We could actually start with a reflection of the first point, and that reflection will be used to be translated along the two lines to come up with the three reflections. But this time, the guide reflection, which uses a reflection and a translation, is similar to this illustration. Let's say, for example, we have here a point. Okay, this is actually a point now. And what if we have here a line? Okay, let me place here arrowheads. The glide reflection is actually the location of a certain point that is a result from a certain drop, in this case, a reflection on a line. Say, for example, it's reflected here. So I'm just assuming it's somewhere here. And then it is being translated by a certain vector on either this direction or the other way direction, parallel to the identified line. So if we're going to translate that, possibly one of the translation is actually this point here. If we're going to look at that, removing the middle portion here, you would see that this is actually a transformation where it follows a certain glide. Imagine a certain eagle or hawk or a certain bird that is targeting its what they call is target in a body of water. So probably it will look like this. It forms like a glide. Okay, so it goes down and it floats towards that body of above that body of water before getting probably a fish or its target. So it's like a glide reflection where it follows a certain drop and then it goes to that form there. So of course, the point here earlier is that first reflection earlier patterns to be its drop, okay, its drop, and then it moves towards to that line. Take note that the translation is actually parallel to our line. So whatever would be the direction vector of this, of course identified as v sub 1 and v sub 2, this will also be the direction vector of the translation. Now, I talked earlier about this is also can be what they call this one, commuted. Okay, so we can start with a translation first. Okay, so say for example, we are going to translate that along, again, the same vector on the line. So probably it would appear somewhere here. And then before we reflect that to this direction. Similarly, we will still get the same point if we're going to start with a translation and then a reflection. Okay? So later on, we'll have some examples as to this. But before we end this video, we're going to present here the formula of identifying the glide reflection of a certain point. Let's just simply talk about a point first. Take note, this point here has components. Let's say for x, we could start with x sub 1 and x sub 2, or you could use x and y as any point in our Cartesian plane. And again, as mentioned, the vector is represented by these components, v sub 1 and v sub 2. That's the direction vector of a line, which is also similar to the translation of the first reflection. The formula is presented in this manner. So we're going to have here the reflection first, let's say on line L, of a certain point x, and then later on translate it with a certain vector. This is actually equal to this form. Since reflection is to start first, we're going to take the reflection of x. So we know the formula for the reflection is x minus twice x minus p in the unit normal vector times your unit normal vector. This is the formula for the reflection, where p is any point on our given line. Okay, any point on that, and the unit normal vector is the unit normal vector following the relationship to the direction vector. We know that already that the normal vector has components, negative v sub 2 and v sub 1 pertaining to the given identified vector, and we know that the unit normal vector is identified as that normal vector over the length. Okay, so we'll have examples for that later on as well. And to complete the formula, since we started with a reflection, later on we're going to translate that reflection somewhere here using the given vector. So you will have here plus your vector v. Okay, so we're going to add your vector v here, but take note, the components of the points in the vectors will be considered. This is the first formula when I talk about reflection first before translation. If we're going to start with the translation first before the reflection, and as mentioned, it will result to the same point here. This is the formula. If we're going to take the translation first of point x, okay, and then we're going to take its, we're going to take its first reflection or reflection along line L. Simply manipulate this in such a way that we're going to combine that from this direction. So you can have here x plus your vector, okay? The vector. Let's remove the bracket so that we could actually operate them. So we're going to add them first, or take the translation of vector v. Then you take this as a whole as one. Then what do you call this one? We're going to reflect that, okay, to our line. So again, this will be taken as 1. So you have here x plus your vector v minus your p, again a point on our line, then unit normal vector times your unit normal vector. These are the two formulas depending on which you're going to consider first. But generally, you will get the same result. We're just going to follow the specific formula for a specific situation. We are assured that we will have the same result, just to make sure that we can actually use these two formulas. We're going to take, for this second, take the translation first. In that translation, similar here, will be reflected along line L. Or, you take the reflection of x along line L, and then you add the certain vector as your translation. Again, it depends on our problem. Again, we will have some examples for this, and hopefully this clears up the glide reflection. Thank you very much for watching.